I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to explore derivative of exponential function at y-intercept using definition of derivatives. So we are given a function f of x which is b to the power of x, whereas you know b is greater than 0 and b is not equal to 1. We need to find the derivative of this function when x is equal to 0. So that is what we need to find. I hope the question is absolutely clear. You can pause the video, answer, and then look into my suggestions. In case you need my help, you can always send an email on the address given. We have been consistently uploading videos on YouTube channel, which is there for last 15 years, and now we have crossed 20,000 videos. This is all thanks to you for your support and suggestions.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandilani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let us look into the solution and understanding of this particular question. So we are given an exponential function, f of x equals to b to the power of x. We need to find the slope of tangent at the y-intercept where x is equal to 0. So let's try to understand the equation now. So let us say we have the coordinate plane on which I'll sketch a graph of an exponential function which is in general b to the power of x. What we really need is to find the slope of tangent at the x-intercept, which is this particular point. So we need to find the slope of this tangent at a point which is defined with x equals to 0, the y-intercept. So this slope will be f prime 0 for the function b of x. Perfect? Okay. How do you find this? We'll go with the definition, which is f prime x is limit h approaches 0 for f of x plus h minus f of x over h. So let me write down. You could find this as f prime x, and in our case, we are taking x as equal to 0. So in that case, it is going to be what? It's going to be limit h approaches 0, f of 0 plus h minus f of 0 over h, right? Where h is very, very small as compared to 1. So for most practical purposes, you can take the value of h as approximately equal to 0.0001. Now that indeed is extremely small. Substituting this value, you can find the derivative of the function b to the power of x at x equals to 0, right? So let us do the general derivative and then we can specifically find for some values of b. So again, f prime at 0 is given to us as limit h approaches 0 of f of a plus h, a being 0 for us. So 0 plus h minus f of 0 over h. Now in our case, the function is given to us as b to the power of x. And therefore, we could write this as limit h approaches 0 of b to the power of 0 plus h minus b to the power of 0 over h. So that is equal to limit h approaches 0. We can multiply, right? So addition means multiplication minus b to the power of 0 over h. Now, as you know, b to the power of 0 is equal to 1, right? Substituting that, we get what? We get limit h approaches 0 of b to the power of h minus 1 over h. So this particular expression, limit h approaches 0, b to the power of h minus 1 over h, is basically f prime h, is the slope of tangent line at the y-intercept where x is equal to 0. You get the idea. So if we have a general expression here for any exponential function, this is the exponential function. In that case, the derivative indicates that the tangent slope, let's say m, is equal to limit h approaches 0 of b to the power of h minus 1 over h. Perfect. So that becomes the expression. Now what you can do here is you can evaluate the limit. So let this be an exercise. For different values of b. So we can take 2 to the power of x, we can take 3 to the power of x, and we can also take e to the power of x. And while evaluating, we can take the value of h in this expression as 0.0001. So that is going to give us the result to 3 significant figures. However, here is your general expression, correct? So I'd like you to now pause the video and answer this question. In case you want to learn from me, feel free to send an email on the address given, or you can also register at our website. So we did these calculations, and here are the basics. So if the function is b to the power of x, and we need to find the derivative at 0, for different values of x, it could be 1, 2, 3, and e. Well, normally 1 is not taken. So we derive the expression as b to the power of h minus 1 over h. And we need to explore the values at 2, 3, and e. At 1, it is going to be 0. It's a horizontal line, right? So when you evaluate, what do you get? Here are the results, correct? So what you notice is, for a horizontal line, it is 0, of course, which is not an exponential function. But for 2, it is less than 1. And for 3, it is more than 1. And for b equals to e, it is exactly 1. So you see, what we have derived at is that if your function y is equal to e to the power of x, then the derivative of this will be also e to the power of x. The reason being that the derivative at 0 for e to the power of x is equal to 1, right? Which is right there. So if you have an exponential function e to the power of x, let me sketch it here. In that case, slope of the tangent line at the y-intercept is equal to b 1, which we are saying f prime 0, correct? So that is speciality about the Euler's number e, which gives you an excellent value. And that means that the derivative of the function is basically the value of the function at any point, because the derivative or the slope of the tangent at y-intercept is 1. So y-intercept where x equals to 1, right? E to the power of 0 or anything for that matter is 1. So at this particular point, we found that slope is also 1. You get the idea. So that is a very interesting number to look into, and that becomes a base for finding the derivatives of exponential functions. I hope you understand and appreciate it. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. Here is an email address on which you can always contact us and also register at our website. Thanks for your time and all the best.